In this example, we're going to be proving the following. If the square of a matrix is equal to the 0 matrix, then the only eigenvalue of that matrix is lambda equals 0. So recall that what it means for a matrix to have an eigenvalue means that if I take that matrix and I multiply it by a vector x, that is equal to just a scalar multiple of that vector x. And specifically, it's the eigenvalue times x. And this value could be anything. It could be 7, pi, -2, whatever, or it could be 0. But what we want to prove is that if a squared is 0, then the only possible eigenvalue there is itself 0. Well, first of all, if I know this is true, if a has any eigenvalues, then a vector times a is equal to that vector times the eigenvalue. So I'll start with this as my starting point. Then what I'll do is I'll left multiply both sides of this equation by a. So this is a times ax equals a times lambda x. Okay, well on the left I can drop the parentheses. A by a is a squared, so this is a squared x. On the right, lambda is an eigenvalue. It's just a scalar multiple, so I can pull it to the front. So this is lambda ax. And then let me re-parenthesize this as well. Now over here, what is a squared? Well, a squared is the 0 matrix. So I have the 0 matrix times x is equal to lambda ax. And the 0 matrix times any vector will be the 0 vector. So let me do that. 0 vector equals, and now I've got lambda ax, but what is ax? From my very first line, a times the vector x is lambda x. So I can rewrite this, that ax is lambda x. Okay, well now these are both scalar multiples, so I can multiply them together, and I have lambda squared times x. And now I want to make a crucial point. For a to have an eigenvalue, the assumption we were making here is that this is for the vector x not equal to the 0 vector. And why do we assume that? Well, because let's say we did allow x to be 0. Well then, 0 vector times a matrix comes out to be 0 equals some number times a 0 vector. Well, that's always going to be true. So then a would have literally every possible eigenvalue you could think of, because all of them times the 0 vector gives you the 0 vector times this matrix. And so it's really not a useful definition to allow the x vector to be 0. So we exclude that one. So we were assuming all the way through here that x was not 0. And now look at this. A vector which is not 0 times something gives me the 0 vector. Well, the only way that could be true is if lambda squared equals 0. And if lambda squared equals 0, well, square root both sides. Lambda is plus or minus 0. Both of those are just 0. And there we go, tombstone. This proof has been laid to rest. I've shown that if you have it, that a squared is equal to the 0 matrix, then the only possible eigenvalue of this matrix is 0.